Pascal's principle. Pascal's principle. We have a liquid, okay, and we know at point P in the depths of H, it has P plus external pressure plus rho GH. This is on the surface. If we put something on top of it, okay, then we'll have to see the change. The change will go this way, okay. The change of pressure, the change of the surface pressure, and with this one. And we found that this is zero because H never changed. In other words, the change of pressure at this point equal to change of pressure at this point. This is called Pascal's principle. Pascal principle. A change in pressure applied to an enclosed incompressible fluid is transmitted undiminished to every portion of the fluid and to the wall of the container. This is okay. Pascal's principle at the hydraulic lever. We see this kind of we call it is a lever, hydraulic lever. The characteristic of this one, this is very small AI, this is very large A output. We put a force F1 pressure tape, and this one we go up, you get a FO output. What the relationship, and we see this one, Fi over AI, the pressure AI, this is delta pressure, that equal to this one delta pressure. This is what the FOAO. Now from this we can find FO equal to Fi times AO over AI. If this area is much larger than this one, we can find FO is much larger than this one. So the jack can pump up the car because force can be very large. At the same time, we see the volume of the liquid oil you go up equal to the volume of the liquid go up. Okay, this volume is the depth DI AI, and this value is DO AO. They equal the same thing. So we find what P output is very large and D output is very small, very small. So in other words, the work done is the same. This is the work done by input force. This is the work done by output. That's same. With a hydraulic lever, a given force applied over a given distance can be transformed to a greater force applied over a smaller distance. Work done is the same.
This hydraulic press will be used to show how fluid pressure can multiply a small input force into a large output force. Pressing this lever down with the force of 2 hands is enough to break a piece of wood or bend a thick piece of metal. This animation shows how it works. 2 oil-filled cylinders with different diameters are connected by a tube. Each cylinder is a tightly fitting piston. Pressing down on the lever moves the small piston down, increasing the pressure in the oil. The increased pressure acts on the larger surface area of the second piston, pushing it up with a force that is larger than the downward force on the small piston.
When an object is submerged in water, the water pressure on it increases with depth. We can use that pressure to hold a glass plate onto the bottom of this truncated glass cone, which is filled with air. The air pressure on top of the plate is less than the water pressure on the bottom of the plate. The difference in pressure results in an upward force that holds the glass plate onto the bottom of the cone. If we turn the cone over so that the small end is down, the plate will no longer be held against the cone. What causes the difference? As this graphic shows, the area of the pressure differential is smaller for the small end of the cone. That results in a smaller total upward force on the plate.